Hello and welcome back to an introduction to the Wolfram programming language. Today I will be covering functions in the Wolfram programming language. Now functions are more like mathematical functions. You'll have a function head and an input. The input will be some variable name followed by an underscore. And as you might have noticed already, this X is green and italicized. This is the way of Mathematica letting you know that these are the pattern-matched variables. So if I run f of 2, I will get 2 times sine of 2 divided by e squared. Another neat feature is that Mathematica does not like to evaluate, say, sine of 2 or e squared. It evaluates if I do one of the following. If I put a real number, which is to say a number with a decimal, I will get the numerical approximation. Or if I do in, I will still get the same approximation. Or if you've seen my typical lazy way that I've seen others do, a double forward slash and then in. The double forward slash means apply this function head to the given argument. Now what about a function of 2 variables? Same as before, just simply put a comma between and specify that this is the new function. So let's say f of e comma pi times cosine of e squared. Same thing as before. If I specify double forward slash in, then I'll get the numerical approximation. And now which one is the real f? Well, both are. If I give f of a single argument, I get x times sine of x times e the negative x. Now if I give it 2 variables, it will specifically give me y times cosine of x squared. Pretty neat if you need to write multiple definitions for a single function. Or if you needed to give a particular result under particular circumstances, like for t here, let's say I wanted to just do t of fish. Now that's just a single variable, but as you can see, this is for 2 variables. What happens is, this here is a way of saying default to 2. When I put a colon and then some input, it will default to this when input is not given. Now if I give t of fish comma pi, I'll get fish times pi because it acts in place of y. So if I need to, say, be lazy and don't need to put a particular input, I can specify a default input. And then I can also specify functions have particular setups like this. I can say that some input here and then a list here. So if I define function of, let's say, sine of t, cosine of t, comma t to a to b, because this is a function representing integrate, I will get the exact value. Now, what if I didn't do it the way I was supposed to? Let's say I put sine of t, cosine of t, and then just put t comma a comma b. It will not evaluate. It is just an unevaluated symbol. I can still manipulate it as input and or output, but it will still remain unevaluated unless I put braces for a list. And then it will give me the same result. Or if you need a function to take particular input types, you can specify that. function as a function of integers only. If I put fun of 4, I get 16. If I put fun of 4 point, it won't return anything because 4 point is a real, not an integer. Then fun of 2.5 obviously won't return anything. And then fun of x, where x is undefined, won't return anything either. And then let's talk about one of my favorites. A function of an indefinite number of arguments. This is particularly useful for patterns like in mathematics here. And in this case, I can even construct Pascal's triangle just by simply using this prod of I and then k minus I of a double table. I can even do prod to create equations if I want. Of an indefinite number of arguments. I can then even do anonymous functions, or functions that don't have any heads. In this case, let's just place this here. Now, if I define f to be this function, it will act as a function head. All symbols can be treated as function heads, but not all symbols will evaluate as function heads. So like this f is defined as function here. F of 1, 2, 1 squared plus 2 squared is equal to 5. I can do the same thing here with apply, which basically takes a function head and applies it to a list, where the list is now the arguments of the said function. Now, if I were to change this to say 2 and run it, it will still run just as before. 2 squared plus 2 squared is 8. Or I can use the syntactical version of apply and still get 5 back. Or if I really want to, I can simply modify this one here and just treat this whole thing as a function head, and then apply it to these arguments and return 5. Recursion is also a nice thing in Wolfram. It works pretty smoothly, pretty simply. This is this Fibonacci sequence. We'll return the 5th argument, the 12th in the series, or sequence rather, or the 125th. And oh, would you look at that? This is going to take a really long time because, it's set calling on itself twice, growing exponentially every time. Well, it's taken too long. What can I do? I can simply tell it to abort. In order to abort, you select a particular line, you hold Alt, hit period, and it will abort the evaluation while it's still running. To check if something is still running, you can look over here to see that this bracket here is highlighted. It's bold. And to abort, just Alt and a period. Wolfram also likes to simplify where it can. Sine and arc sine, or hyperbolic sine and arc hyperbolic sine are inverses of each other at every point in the complex plane. Therefore, it'll simplify it down to t. Another interesting feature is that all of these are also functions. Head will return the function head of an argument. So as you can see, 1 is an integer, 2.4 is a real, pi is a symbol, 3 plus 4i is complex, I is complex, not imaginary, sine of t has sine as its head, t has symbol as its head, and t squared has power as its head. The reason why t squared has that as its head is because the full form of these takes these form: power t comma 2 complex 3, 4, complex 0, 1, 2.4. The asterisk is just a short way to write out an infinite sum, or not sum, an infinite phrase, typical in Wolfram. And you can even see that this is a list. It is also a function, using brackets and having arguments. Anyways, I hope this clarifies what functions are in the Wolfram language and how they can be used. Have a great day.